now that we know how to draw angles and we know how to find positive and negative coterminal angles, it's time to take a look at reference angles. A reference angle is a positive acute angle formed by the terminal side of the angle on the x-axis. So I want you to really circle or underline x-axis. And also make a note that your theta must be between 0 and 360. So if you have a negative theta, you're going to have to find a positive coterminal angle between 0 and 360. If you had something really big, like the 990, you're going to have to keep subtracting 360 until you get to a positive number between 0 and 360. Now, if I were to find a reference angle, just drawing this in general, let's say that this right here is my theta. Your reference angle, which has the notation theta prime, is going to be the distance from the terminal side to your x-axis. So I'm going to connect this terminal side to my nearest x-axis, which would be the positive x-axis for this one. So that's my theta prime, which means that there's rules for each quadrant. In the first quadrant, theta prime is equal to theta. Okay, they're the exact same thing. Now, let's say that my theta prime needs to be identified when the terminal side is in quadrant 2. If this is my theta, theta prime is going to be the distance from my terminal side to the nearest x-axis. So that would be the negative x-axis here. There's my theta prime. In order to get the value of theta prime, so this degree measure right here, I'm going to have to take 180 degrees, because this is 0 to 180, and subtract or get rid of theta. So 180 minus theta will give me that measure. So I'm going to write that. I'll keep it this color. Okay. Now let's take a look at if it were in the third quadrant. And now I'm kind of writing this all over. So if it were in the third quadrant, my theta prime would be the terminal side to the x-axis. So that right there. This, you could see, is larger than 180 degrees. It's between 180 and 270. Now 270, I don't want to use that because that's the y-axis. I want to use the 180 still. But instead of doing 180 minus theta, that won't give me this right here. I want to do theta minus 180. So theta and then minus 180 would just give me that section I want. Okay, and that's if it's in quadrant 3, that's the rule. Last one, if it's in quadrant 4, so there's my theta right there. If it's in quadrant 4, here's my theta prime, connecting my terminal side to my x-axis. A common mistake is trying to connect it to the y. We can't do that. So the x-axis, I don't want to use the 270 because that's along the y, but I do want to use that 360. So when it was in quadrants 2 and 3, we used 180. When it's in quadrant 4, we used 360. So this whole rotation would have been 360, and we just want this chunk right here. So we're going to do 360 minus theta. And that's if it's in quadrant 4. So basically, you want to have these rules memorized for finding theta prime, or sometimes you can just take a look at it and say, how far away is it from the x-axis? For example, if I look at part A of example 5, First thing I want to check is theta between 0 and 360? Yes, it is. So I can go ahead and write my quadrantal angles in degrees, because it's going to be a positive theta between 0 and 360. Now 135, we're going to start at 0 and rotate it until I get my terminal side. So 0 to 90, and then 130 is going to be between 90 and 180. I know that 135 is 45 degrees past that 90. So my terminal side is going to be right here. Okay. Theta prime is connecting my terminal side to the x-axis. So here's my theta prime right here. You could just ask yourself, okay, 135 is 45 degrees away from 180. Or you could have done the rule, theta prime equals, it's in quadrant 2. So the rule is 180 minus theta. And in this case, theta was 135, so that's 180 minus 135, or 45 degrees. Part B, we have theta of negative 105. Now this is not between 0 and 360, so we're going to go ahead and add 360 to try and find a positive coterminal angle. If you add 360 to 105, you get 255. So I'm just going to put 255 right here. 255 is between 0 and 360, so now I can go ahead and label my quadrantal angles. .255 is between 180 and 270, so I should know that I'm going to be ending up in quadrant 3. So I'm going all the way past 180. Now 255 is going to be closer to the 270 than the 180, so I'm just going to kind of draw it like this. My theta prime is connecting the terminal side to the x-axis. So this right here is my theta prime. And the rule for the third quadrant says that theta prime is equal to theta minus 180. See how if this is my theta and I get rid of 180, it gives me the section that I want. So theta, I'm going to use the 255. 255 minus 180. Scooch that down a little bit. That would give me 75 degrees. So theta prime is 75 degrees. Okay, part C. .325 is between 0 and 360, so I'm going to go ahead and label my quadrantal angles. My initial side's right here. And now, just by looking at it, I can already tell 325 is between 270 and 360, so I am going to end up in quadrant 4. Starting at 0, I'm rotating all the way around. And then the 325 is going to be a little closer to the 360. So I'm just going to draw it like this. It's not too close, but it's closer than to the 270. And theta prime is right here, connecting my terminal side to the x-axis. When you're in quadrant 4, theta prime is 360 minus theta. So 360 minus 325, we're 35 degrees.